Alright, now we have a real world example of a problem using of a differential equation that we need to solve with separation of variable. And the question we're given is we need a model national income. Alright, so the question is, let Y represent the percent of the remaining income spent on luxuries. A commonly used economic model that relates to three quantities is dy over dt equals k 1 minus b times 1 y minus a. Alright, and here we are given that t is in years and assume b is 75%. Here we can pause the video so you can copy it down. I hope you guys copied it down. I'm gonna keep going, so I'm gonna erase all this. Alright, so we know the equation that was given to us was dy over dt equals k 1 minus b over y minus a. Alright, so the first thing we're going to do is we know what b is. B was given to us, and b equals 75%. But we know the percentage, we just move over 2 decimal places, and it would give us 0.275 as a decimal. So we just plug that in for b, and we know 1 minus 0.75 equals 0.25. And 1 minus, it equals 0.25. So our new equation would look like dy over dt equals 0.25 k y minus a. Alright, so now we need to separate the variables. So we want y with the dy and we want the dt on the right side. So the first thing we're going to do is we're going to divide both y minus a so that we can move it over to the left side. And we're going to multiply by dt, multiply both sides by dt, so we can move dt over to the right side. So our equation will look dy over y minus a equals 0.25 k dt. Alright, now we need to find the integrals for both of the sides. And here we're going to be finding the integral in respect to y. Here we're going to be finding it in respect to t. Because we're finding it in respect to t, we act this whole thing as if it were a constant. Instead of k as a variable, we're going to treat it as a constant. 0.25k as a constant. Alright, so you're right. dy over y minus a equals integral 0.25 k dt. Alright, and we know the integral of dy over y minus a would become ln of y minus a, and the integral of 0.25k. As I told you, we're treating this as a constant, so we're deriving in terms of t, so it'd become 0.25 k times t. And now I'm going to continue on the next. Erase this to continue. Alright, so right now we have ln of y minus a equals 0.25 k t. Alright, now that we have this, we want to get y by itself, y on the left side. And to do this, we need to exponentiate both sides. So we're going to get rid of ln, and we're going to put this to the e power. Figure out the plus c here. And we're going to put these to the e power so we can get rid of the ln. So we would get y minus a equals e to the 0.25 k plus k t plus c. And we know that this c would come down and multiply with the e. So it would look y minus a equals c times e to the 0.25 kt. Alright, we still don't have y by itself, so we need to add a to both sides. Get y equals a plus ce 0.25 kt. And here we have found the modeling for the income, and we are done.